So just confirming again, everybody has come for this seminar only, right? Nobody has come for any other seminar. So today's topic is, okay, so I want to talk about a recent project that we started. Some of you may have heard of it, some of you may not. It's a subscription-based electricity pricing, and it is with NYSEG. There are other utility companies joining in, but this is a pilot that we recently started. And a bit of background about me. My name is Madhur Srivastava, and I am in chemistry and chemical biology. I'm a data scientist. How I ended up in chemistry and chemical biology, I will tell you if you need to know, I think. But don't go by this name. So this is the article, I think if some of you have read, came with that we started a pilot project with NYSEG, saying that we all are subscriber to NYSEG, right, I believe, and you know that you pay every month, they bill you something. And how many of you like your electricity prices? How many of you think that they are very high? And others, how many actually pay your bills? How many actually get a bill? Okay, so I don't pay my bills. I don't like paying bills, so I don't get a NYSEG bill. But some people who get, as you said, how to improve it, and prices are increasing every day. Blackouts are increasing. So how do we come up with a solution that is adoptable? And that's what I'm going to talk about today. This is not a Ithaca-wide problem. It's a nationwide problem. You see every single day, you will see a news coming about some utility getting fined for outage. This power outage has become a common thing. Most common would have remember Texas, right? Where Texas blackout happened. But Texas is an anomaly. Texas does not really go to blackouts. The blackouts mostly happen in California. You must have a PGE, or even Northeast. There's a lot of blackouts that happens all across the US. The key here is relatable. Rochester Gas and Electric is just next door. There is a now call to make it a public utility. They are fighting that call. And Avangrid, which is the mother company of NYSEG, parent company, they are going through a load shedding in Connecticut, where they also operate. And you can see their CEO made this comment, I think very recently, that the prices are increasing and please reduce the prices from the supply side. So this has become a major problem across utilities. And we went to an NSF I-Core program where you basically identify a problem. NSF has this really nice program. I was the faculty and Shikhar was the graduate student. We talked to a lot of utilities, and this is where we got the information that there is a power outage problem and high electricity price problem, and which is going to go worse because everything is getting digitized and everything is getting green. So there is a problem which is happening, and they are trying to manage this part. A fun fact about Portland General Electric is that their top batch is a Cornell alumni, and she told me there's a trans-Pacific line coming from China to Portland. So all the data servers will be hosted at Portland. So you can imagine the demand surge for electricity there. So going back to basics, you have these power generation things like wind, solar, gas, coal, nuclear, and then they transmit the energy to substation, and then it goes to our residential, commercial, and industrial complexes. It looks simple, it is actually not that simple, because when we say residential, commercial, industrial, some areas are known, some areas are not known. Commercial, for example, if you go downtown, there are both residential and commercial buildings. More importantly, residential complexes, the apartment complexes come under commercial, but most of the residents live there. So these are simple characterization, but it's most likely more complicated how we characterize it. There is also error when you code it. So sometimes you get a cheaper or higher price if there's an error, whether you are tagged as commercial or residential. So what happens, there's a transmission line. You have seen all these big fields, big lines coming through. They supply the electricity to substation, and these are distribution lines which you see across the region, which gives electricity to our home. So how does it work? From the consumer side, there's a demand generated. When you switch on a light, there's a demand generated. That signal is sent to the generating house that, okay, we need this amount of power. and then that generator creates an energy, and then it is transmitted back to home. This is a very simple model. If you're a coal power plant can ramp up that production anytime because it is decided by the consumer, and so is with nuclear and gas. That is not so much to with the solar. That's where the problem comes. You know, if you have an intermediate or sort of green energy, they are not dependent on what demand you need. They are generating X amount of energy at a given point of time. If demand is there, that's good. Otherwise, there's surplus energy that needs to be taken care of. So that is a standard model, but that is more towards the conventional energy generations, and those are the problems that many utilities are facing. How do you transfer to the renewable? So how your bill is charged? So you get electricity.
Excuse me.
Are you getting the audio? Okay. So when you see your bill, how that bill was generated or how that bill is generated, what are components to it? One is when coal, gas, solar are charging certain amount, right? They are selling this electricity at a particular kilowatt. That is the price that is added. Then there are rate structures. For example, utilities go to regulators, say, I have this infrastructure cost. I have people, I have a real estate property, my offices. These are my actual costs, and I want X amount of profit. And that's where regulators approve. So cost of this added to these rate structures add up to that cost. Then the usage trends. Sometimes you use more, sometimes you use less. Time of use. If you're using at a peak load, you will charge different rate. If you're using a non-peak load, you're going to charge a different rate. And in efficiency opportunities, some of you may have heard that, why don't you use solar or have a sort of contract, you will get a cheaper electricity. So there are certain, or government subsidizes you if you use certain things. Most common is if you get an EV car, you get a sort of subsidies in certain areas. So those are the things that go to your bill, and then finally your bill is generated. From the supply side, the rates are decided whether you are on peak rate or off peak rate, whether you're using it when there's a big grid load or not. And from the demand side, poles, there's a loss happening, electricity loss is happening, there's a cost of construction, maintenance cost. Operation costs include both meter charges, when you install meter, as well as meter reading charges. There's a person who's actually reading the meter, if you're a smart meter, maintaining data, and so on and so forth. Those all go into that. And of course, service charge. To generate a bill, paper bill, you will be surprised to see, I was just surprised, it costs $7 to $12 per person per year just to receive a bill, right? And this is all you are paying for it. You may not even read the bill. Even digital bills, there is a cost to it. So those things come into picture. Some utilities directly charge you, some utilities don't charge you, but they incorporate in your bill. There are also bilateral contracts. For example, solar, you must have got emails from solar farms. If you use our thing, you will get a cheaper electricity, and so on and so forth. So how that bilateral contract works? So there's a solar farm in here. What happens is, if you have a contract with them, what they do is they supply X amount of energy to the grid, and then you extract energy from the grid. Of course, you may be extracting different energy from it, but the thing is they have supplied it and you have taken it. That's the thing. And you are going to pay the rate that you have talked to the supplier. It is worth noting that utilities and distribution companies are electricity providers of the last resort. You can have your own supplier and you can have that rate. Utilities are going to charge a particular amount to it. But if you are nobody supplying electricity, they are the ones responsible for supplying electricity. So if you have a bilateral contract, some of the industries do that. That's why they get a cheaper rate. That this is the power coming from this source. So if you are a NYSEG subscriber, you have three options of paying your bill. First is what most of you have seen. You get a bill, you pay it. That's it. Based on your monthly usage. You first high prices, uncertainty bill. When winters you may get more bill, summers you get less, and depending on the usage. Second option is dynamic bill. Some of you, if you go to your website, you will see dynamic bill option where peak load you will be charging differently, non-peak load you will be charged differently. So they use it based on when you are consuming the electricity. Not very successful. It has not taken much enrollment and no information. Anybody know how those dynamic pricing are charged when you are enrolled? I don't know. I think they gave me an option. I said no, thank you. I don't know when to use, when not to use, because I don't know how much I'm going to save, and I have to change my behavior a lot. And then the third option is balanced budget. Balanced budget is you pay one price per month. At the end of the year, if there is a remaining balance, you have to pay that, or if you have to consume less, they will return you the money. The problem with that approach is when you pay one rate, psychologically you are using more. You end up using more. And the second problem is you are happy till 1 year. At the end of the year, you get a $300 extra charge. So no more ice cream for your kids during summer. So, and I have a story. There is a Northwood Apartments next to airport. When Shikhar was coming in, I was helping him getting moved in. And you know, nowadays they require security deposit or sort of validation. That person said, "Oh, you used to work for NYSEG. I hate NYSEG. I have to pay $350 right now." And he had a hard time when I used to say I work for NYSEG to getting an apartment. So people do get upset. A slightly background how dynamic pricing works is certain time off peak hours you get a lower rate, shoulder rate is where you get a fixed rate, and on peak hours you get a higher rate. So depending on this demand and supply, this is not fixed. If everybody changes their consumption pattern, the peak load changes at a different time, you will get that rate. So this is the dynamic rate. Difference can vary so much. This is just a Florida data. 25 cents per kilowatt to 12. So you are actually paying half the rate if you are using off-peak hours. Mostly this is used by commercial and residential sector and depends on the state regulations, but also there are some companies allow residentials to use it, and New York is one of them. So what's the problem in electricity consumer? You get a very surprising, very high bills. There's an uncertainty of this. Nobody does their math. They say they just keep. This is the only thing that you don't have control over. You know what your rent is going to be. You have control over whether you want to go to a restaurant, eat food or not. Electricity bills, many people don't have control. You have to use it and you have to pay it. Even phone bill you have control. If you have a data plan, you can choose not to use data. In this case, no. And bills are rising. Recently, 7 to 8% are increasing in New York State. Massachusetts is increasing by 42%. So every state is going to increase the bills, and you are going to see a higher bills over the period of time. So we came up with a solution that came with my usage. I said, why I'm paying variable rate? I tried to develop, can I have a subscription-based model? And that's how I reached out to Avangrid. The idea is based on your personalized consumption and sort of grid usability, you have a choice, and everybody has a own personalized choice. It's not that here in the room everybody gets the same choice based on your own bills and your consumption pattern. You get 3 to 5 prices. You can choose any of those prices, and based on those prices, there are certain consumption pattern that you stick to. That how do I consume electricity? Higher price you choose, you have more choices in terms of what you can use at what times. If you have use a very low price, then you have slightly regimented regime in terms of how do you consume electricity. So that is the idea that we came up with, and the reason behind was, first of all, certainty bill. You pay one bill, and as I described in the previous slide, because prices are variable, so then you can change the consumption to maintain that bill rather than going overboard. You choose your own payment. It's not that somebody gives you a payment. You can say, I can want to a higher price, this is my affordable price, this is not. Control over your bill, same as you know what is going to come next month, and reduce bill over time with behavior change. Rather than doing laundry at peak hours, you can do it off peak hours. In fact, you can have a smart device which can do laundry at 2 a.m. if you are comfortable with that. So those sort of changes can be taken care of. So this enables it. Benefit to utility providers is optimal load distribution. If you have a peak load, they have to maintain that infrastructure even if you are using it for 1 second. So that's a redundant cost. You are maintaining that high infrastructure capacity even if it is used for 1 second. So that's not a good idea. You can distribute the load and reduce the cost. Similarly, infrastructure upgrade is delayed or avoided altogether depending on the consumption. Maintenance cost is reduced because if the peak hour, the burnout rates are even higher. Equipment failure becomes higher. So those monthly cash flow, they don't have to worry about generating new bills. They know this money is coming because of this subscription price. They don't even have to generate bills. And reduce peak load. This is the thing that they want to basically say, I have this peak load problem, I want to reduce at those locations. So how does it work? What's the behind the scenes? I'm going to come to the subscription from the user side, but from the utility side. Solar, wind, gas, coal, they are generating this basically energy. First is to find a critical substation. All substations are not at risk. Some substations are working below power. Find which of them are critical, where upgrade or maintenance may be needed. And then find the residential, commercial, industrial complexes which are contributing to that peak load. Everybody is not culprit. Some of you may use very little electricity. Why you have to change your behavior? You are all good. Some people who are using more electricity and have a high variability are the ones who are the culprits. So identify them, quantify how much they have to change. Not everybody has to change a lot. At what time? Somebody has to change 0.5%, somebody has to change a lot. So those sort of precision or individualized behavior utilities want to carry out from their own data, smart meter and all the data that they are available with. From our side, from the consumer side, the thing is when you have this sort of data, it comes from an AMI data, I'm going to talk about it slightly later, you start studying the pattern, behavior pattern of one individual user. So you can see there's an overlap map. So a set of users have a similar consumption pattern. And this is not just the load data, this is a structure similarity, the pattern data. It's not actual use data, but how you are in terms of patterns. You may actually have a higher consumption of electricity, but the pattern is same. So what happens is you identify those customers, study their profile when they are using it off peak hours, on peak hours, and because you have 3 to 5 years of your consumption data, we can see, okay, these are the changes you made. It's not that every day you are using from 6 p.m. to 8 p.m. that amount of electricity. Sometimes you have changed those behavior for certain reasons. So identify those things and then calculate the pricing for that. And that's how the subscription tiers come into picture. You are using the same amount of energy and you are seeing how much you have, based on your past consumption, change your behavior. What's your behavior variability? And then calculate those prices. So a good example you can see here is, I'm not sure it's clear or not, this is a mild user, this is a moderate user, heavy user, super heavy user. These are different patterns which you have found through our data, that these are actually different patterns. People have very different kinds of patterns of consumption. And if you want to choose your price, this is what is happening. This is a one set of consumption pattern. You may actually have multiple variation. So using that variation, we choose the price. Why? Because we know that this is, you have already used this thing, so you are easy to switch for you to that pattern or make those changes. Yeah.
I'm sorry, I just want to clarify what the subscription, how the subscription rate is parameterized. So you're providing like a choice of a time of use rate that you subscribe to, or because like I know subscription typically refers to like a a level of demand.
Yes.
But this is different, right?
Yes.
Okay.
So what we are doing is, if I have to define a price for you, how do I define? One is use your past consumption pattern and calculate different prices that are possible. And now the question is, if I choose a price on a behavior that you have not used before, it is very difficult to switch to that behavior change. Question is, even in a 5-year behavior, you have chosen a very different behavior. So we can make that the metadata and see these are the behavior you can make changes and then decide the subscription price based on the rate that we discussed in the previous slides. So that's how you commit. Balanced budget does it differently. Balanced budget take mean, which is a bad idea. Like mean is, yeah.
I find this very difficult, like an application where if you're talking like in the entire city and you try to, in my work we try and do something similar to this. My biggest challenge is actually residential when it comes to rental. So this zip code, this address, it has a certain behavior when it has a certain tenant. Different tenant would have a different appliances, different behavior.
Yes.
The data would be so messy, you can't structure a pattern for that.
Actually, an excellent question, because some of it I'm going to answer through my next slides. Here is who is giving us the data. The good thing is access to data. The NYSEG good thing is they have all these data themselves. So they have a proper AMI data, personalized data, zip, some data is available, say zip code, household. Key here is residential, commercial, as you mentioned.
Well, I have everybody.
So
but particularly is the residential rental is the problem.
Problem. And the key here is there are two ways to deal with it. So some of them they do error, that they miscode it. That is the human error part. But there is another. That's why we do structure similarity part. Question is we are not characterizing in terms of residential, commercial. We are characterizing based on the usage. So basically, although you are commercial, but your pattern is more like a residential. So that becomes apartment complex. But the bigger change, as you mentioned, in commercial is much more variability. Law officers have a very different pattern from a restaurant, right? Similarly with a barber shop. So those further classification. So those classification mapped with the individual consumption pattern. So that's where it's a richness of the data that we have. Then we can map one sets of data with the other sets. So that data talk to each other. More importantly, as you mentioned, this is the substation data, which has never talked to the consumer data, right? AMI data does not talk to the substation actual trans. So then you are also making them talk to each other. So then you know this much electricity is transmitted, and this one collectively should be the received one. We can also measure the losses. So that's the advantage that we have. So one of the key is data scarcity is the bigger problem, and that's where our NYSEG is providing all that facility. Energy manager, if you have enrolled in NYSEG, you see this is something called energy manager. There is people, we have smart where they do all kinds of data analysis because those data has been transmitted by Avangrid.
Yeah.
Yes.
Actually, in the slide itself, for the heating season, you are showing from midnight to around 6 a.m. It's like off-peak hours. So what is it exactly? Like, are we not using electricity, or are we not using because in those hours itself, in the heating season, we use heaters for that time.
Heating. Good question. We assume that we are going to have heat all the time, but heating system works for every household differently, right? So, for example, some heating systems, they don't operate continuously. They say, okay, if temperature goes below it, they switch on. And then when the temperature goes above certain thing, they stop, and the room maintains that temperature. So this graph, luckily your question is plotted for this. So you can see that after what you call 40. Oh, this is a day graph, so not the hour graph. But the thing is, even though it's an off-peak hour, the heating is not on continuously.
But are you taking automated heating system into consideration or the manual heating system into consideration? Because during manual heating consideration, for example, me as a person, I don't like to sleep in a cold weather. You need heater. So sometimes accidentally, or most of the time accidentally, put your heater on.
Yes.
This is in case of manual heating.
Yes.
So is your data upon the automated heating system?
At this point, we do not differentiate that part. My thing is, what's the overall consumption at that point of time? Okay. So now, as you mentioned, in that case, it will happen that there will be two distinct patterns for it. Question would be whether those two distinct patterns are separate enough or not. There can be a sort of load variation, but the thing is whether that load is worth the difference or not. So that is something, a good question. At this point of time, I would say, we just measure the similarity of load pattern and load in that aspect. So we have not segregated in terms of heating. And this, how do we do structure similarity? What happens is you take a load profile, compare with all of them, like 300K users, compare with all of them, create different profiles, and this you can see this, both of them are very similar profile, right? Key here to know is it's 0 to 1. It's saying structure similarity of consumption. It's not in how much you're consuming. So you can actually have one may be consuming megawatts, one may be consuming kilowatts, just to give a rough example. But they have a similar pattern of consumption. And how it is calculated, this formula is sort of approximation of it. This is a structure similarity index measure used in image processing a lot. It was a paper published in 2004, has about 22,000 citations. That's a very classic paper. But if you apply this formula in this data, it is not going to work because that was developed for images. So we sort of readjusted this parameter to get the same feature, but with slightly modified formula. If you need more information from that, I am happy to provide that. And this is where yeah.
Sorry, just on the previous slide, it's kind of like an obvious question, but this isn't something that would be explained by like temperature. So, I mean, this is a really remarkable similarity, but it's not something that could be explained by some atmospheric or.
Actually, it's a very good question. This is saying you have a similarity. Question is, what is causing that similarity? More importantly, why in terms of days? Why 0 to 40 have this sort of thing? Why? What has changed in this? That is where other parameters come. Temperature, right? It can also come with, say, you may have certain other aspects of coming in, right? So
School season,
off school season, bigger house, smaller house, one thing we forget is people living in beaches have a different sort of place. So this tells us there is something, and now we have to dig deeper. That's the segmentation, and then you go into personalized reasoning. Yes, so those are the things, and that's why we have a catalog of income. Income level is also very much important in there. So we have all those parameters coming in. So now, what is this heat map? So if you do a simple analysis, you get this correlation. Customer ID is individual user, and you see a correlation function. And now you can categorize based on the SSIM and consumption pattern. Look, this is A zone, B zone, and C zone. And with A zone, B zone, and Z zone, so you can see different variations. Like this is one type of consumption pattern, this is another, this is third. Similarly, you can see a variation based on days. How one of them is not even consuming a lot, right? These are the low consumers, but some of them are really all over the place. So that sort of separates you the whom to target, whom not to target. And so these people will have actually much more variation in subscription price because they have much more flexibility in changing their behavior too. This will not have. You may save 5, 10, 15 bucks in that range, but the thing is they have much more potential to change the behavior.
I mean, if we go a couple slides back and you can see the off-peak, this one. Is there a way that maybe like utilities can have an app or website can show it to people? So if I own an EV car, I want to charge my car during the down hours because my price is structured such that it will be the least possible. I don't use it, but I can plug it in there.
I love this question because this is exactly we are planning to do. This is an energy manager has done it or trying to do it. This recording is not going outside corner, right? So I can give you a number, how much they get paid for it. Okay. So they get paid $10 or more million per year for all this data analysis that we were talking about. Like they provide 10% reduce in kitchen and everything, and we don't even use it. And then you pay higher prices for this data analysis. There is no digested form. So for us, this data is very important because we can make those 5-10% changes, and that is available. So if you have a smart meter, New York is enrolling in the next 1 or 2 years. Just give information. If you are in Connecticut, they already have it.
Yeah.
So, in fact, this week or last week, we were talking to energy managers, which were talking about how they are doing it across the board. So we got their whole demo, talking to them, and we also try to do, but mostly in a digested form, which I'm going to show you. May not be useful for both of us, but for other people that may be much more useful. So, how do you get data? And this is how I want to show why things have not moved so fast in this sector. This is the data they gave it to me, right? How do you get data? Through box folder, so, right? 2 months. You are so how to get my security, your security, this security, that security. What is what? You know, box is a limit. 50 GB limit. You cannot, a file cannot be more than 50 GB. So that's why you see all this 44 GB, 45 GB. They will first chop it off, upload it for 2 days, then we are going to download it for 2 days, right? And our computer is going to crash because more than 1 GB of data. So if you are do big analysis, you are done, right? So if you ever thought why it has not happened, methods doesn't seem like a rocket science, but the question is how do you make it practical? And good news is this is going to, although this is a box thing, we are working with Corner Center for Advanced Computing to have sort of a nice connect so that they can transmit data there. And my goal is, especially everybody's in systems engineering, any corner student in that at least can work and have access to that. So if you have a new idea, you can actually work on those data. That is my goal. It should not be restricted to just to me, but the thing is, this is what it is. There's also CRADC where they give you social security number, all those personal data that will be stored at CRADC center. But you can see why this is difficult. If you are using box to transmit data and download it, good luck. Another thing, some of you actually may know how the prices, when I was talking about supply side price, remember that these are generators and they bid, they auction the price. So if you have first generator is contributing this much amount of electricity, then the second generator picks up, they all auction it. But the price is charged based on the last utility, watt. So if the coal and gas said I am going to do 100, only they are providing only 1 or 2% of electricity, solar makes money. So if you ever thought solar lobby doesn't want coal to go, you know why. Because their cost is low, but they are getting so much paid. With this behavioral change, that's the key here, and that is for us. You shift the load. You shift the load from here to here, and subsequently, so now you don't need that last 1 or 2. So your price suddenly drops. So if this pattern is sort of done encouragingly, you can see your subscription price, actually your fixed price is going down really. But the question is, this is not collective way of doing. Currently we all are individually working on this, right? That does not help. It has to be done collectively so that price can actually reduce. And that relates to the comment which Avangrid's CEO said, right? The supplier has to reduce the cost and so on and so forth. But if you slightly change the time, cost is automatically reduced. So this is part of the answer. So we started the app, and the reason why we started the app, if people are buying stocks in Robinhood, I never go on a website. Everything more or less done in an app. So why not use an app as an interface to talk to people? And also it's a personalized thing. One thing is privacy. Last thing you want is to supply certain data to external entity, and then we all know how Google, Facebook use that data. Question is, it has to be personalized. So it's a beta free version. We have an advanced version, which I will be showing to Spectrum News this Monday, but it's the beta version. So Shikhar is the graduate student. So if you want to enroll, you simply enroll in this. This is your name, email address, and physical address. Now the next level is connect utility data. So you can go to the NYSEG portal and to other utilities too and connect your data to that, or you can manually enter your bill. And what you have to do is provide your account number. If you have PDF versions, upload those PDF. We get your bills, we get your information, and then the subscription price starts getting calculated. So to give an example, say choose your subscription. This is based on hypothetical case. You have 5 prices. The advantage here is many people actually don't know that they can choose their price. Prices are dependent on time. If you talk to anybody, say randomly, they will know I have a choice of using and changing prices if I use a different time. So this makes you think, okay, I can actually pay $80. So what is needed for paying that $80? And then you say you have to make those behavior changes to make it happen.
I've seen in different states, the utilities actually have an inquiry once you go through the app, and then they will ask you how many appliances that you would have in the house that they are majorly running, like a refrigerator,
Yes.
AC, water heater. If you place those with the numbers, that they can have some kind of estimate, and then anything above and below that, that's behavioral, kind of buffer.
And that is what we want to do. I think the next thing is, here it is. So you enter your own appliances. So your appliances may not be same as my appliances, right? So I can enter, that's the customized part. Second thing is some information, if you're willing to share, when we say microwave, we have this backend data saying this is how much microwave consumes across brands. That's we can get from external part. If you provide a brand, you can actually get that precise, and that's how we start mapping those info. And this is private information. That the question is, this has to have privacy and all of it. To answer your question, one is the big data analysis, but the question is, can you have slightly on a digested form? We can have the ability to see that how much percentage, but the question is how, based on my monthly subscription, am I good for the month? Am I doing the right thing? Green, perfect. I was good for a week, yes, almost there. But I am not good for the day. So even although I have overused what I should be using, I'm still good for the month. So that gives you that daily information, red, green, blue. Now if somebody wants to, yeah.
How do you make sure that the people are actually using electricity in accordance with their subscription? Because you don't want to like send a blackout if like that day they're just, using a lot of electricity.
Can you repeat that question, if I'm understanding correctly?
Or yeah, how do you enforce that? Like what if someone agrees to pay the lowest rate, but they don't actually implement the behavior change that they say they will?
Yes, so that's why we are running the pilot. We want to see how many people do it and how many people don't do it, and what to do with that. That's the question. Question is, you can choose $70 and say I don't do anything. From the pilot version, that's we want to see how much is the acceptance rate. For people who don't, I have some of the options for it. One is if you go beyond certain range,
The rate change to the rate.
your subscription options are going to change for the next year or based on that. So you have to basically eventually pay, but the thing is it's going to gradually change. Or you choose for a premium rate, the way you do it for miles when you lease a car, right? Say 10,000 miles. If you go above it, this is how it's going to happen. But those are things we want to test with the pilot. The people who are adamant of not changing, what's the right prices, and they should stick to that. So those are the things we are going to answer with that pilot. Does that answer your question?
So like related to this question, you need like a certain fraction or a certain number of people to participate appropriately in order to actually drive down the supply price. So how do you ensure, like how do you actually cover that risk? Because I mean, ultimately, like if everyone does what they say they're going to do, but not enough people do it, then you're still going to potentially incur the high supply price.
The immediate answer is, if we want 100 people to change the behavior, we identify 1,000 people.
So an expectation, you're going to get
Precisely.
enough to change supply.
It's like going for a survey, right? We know that 100 people, so that's the key here. And those are the things. The good thing is, if we presume few things, this is hypothetically we are presuming it, but the thing is that has to be data driven. What is happening at the stage here?
I've seen the industry actually, the generators are the sponsors of those initiatives, because if they bring in like a 5 megawatt generating power right now, but the peak is 5.1, they have to bring a completely new
Yes.
generator that they will charge only that much. Their best interest actually to market this.
Yes.
Actually, why is the utility interested in it? Is the other question I have, because like the utility has very little incentive to.
They have, read that news article, the second slide.
Yeah.
They never had it. They wanted to build as much infrastructure as you want, right?
Right.
There's a problem. Problem is, if you have blackouts for a certain duration, Ithaca experienced it on this Saturday, right? This Saturday or last Saturday? There was you have to pay fines, millions of billions of dollars of fines. PG is a classic case. Texas had a blackout. You have to pay millions of dollars of fine. Second thing is how much to do, right? You keep building infrastructure. So this is a now situation where you have to. They want people to moderate because their profits are going to reduce. Plus, you can build infrastructure, but they are going to ask you for a higher rate. Nowadays, that's why you see a lot of protests. Why I'm paying so much? So there's a leeway how much you can go. Same way Facebook, how much you can advertisement. There's a backlash, the public backlash, right? And one thing, again, outside people are not listening. When I was told, we want voters to be happy. Voters influence, especially state legislature, politicians, and politicians can really nail them down because Public Service Commission is the one who sets the rate. NYSEG and Rochester gas electric rate was not approved, whereas Conrad was. So you may actually end up saying that you ask for increase and they will not. So then you have to bear the cost. So those are things which are actually currently happening. So they want those things to happen. And again, specific notification that avoid laundering. So that it's same 5% direction, but what's the actionable part that I should be doing? This is a button. So targeted inside, I show you this thing that we are going to say green, blue, all good. So you can see here, you are all good in terms of daily usage, but you are sort of using a lot of EV and way less microwave. So this also gives you the inherent equation. You don't have to change anything, but at least give you that microwave is all good, EV is the thing that you are using. If you reduce your EV, price may actually even go further down. So similarly, you can see these are the options and you provide those options to us. So you can see green, dishwasher good, heating good, EV, television, so on and so forth. Now with EV, the next option is if you click here, charge after 9 p.m. So what should I do? There's a red line, what I should do. So those are the comments. Like I am saying after 9 p.m. I may say charge between 9 p.m. till 3 a.m. So those are the actionable items you start getting. And at the back end, as you mentioned, the data analysis is happening 2%, 3%, 5%. So currently the partners are NYSEG, Avangrid. Good thing is BG, Baltimore Gas Electric, is coming into. In fact, they told me they want to enroll all their employees first because they like this idea slightly more. Portland General Electric. In fact, I thought I am the one who thought of this idea. Well, no, that never happens. It came from Lawrence Berkeley in 2010. Somehow regulators did not like it. And nowadays regulators are much more open. NARUC is the FDA of regulators. And they, especially lower income neighborhoods, are becoming much more problematic. So now everybody is open to that idea. Rather than pay one and then change the behavior. So we are getting more traction. Edison is the Southern California, one of the utilities is the Southern California. So it is slightly growing in the program. There is a subscription in case you also want to register. This is the best time because if you go overboard for answering your question, NYSEG is going to cover the cost because the pilot. So if you want a lower bill, at least for the pilot, this is an option. Again, actors, it's not going outside the campus. If you want personal details, I can also give because we talk to them frequently, weekly, and I think the amount is going to grow. This is my lab, Signal Science Lab. I call it Signal Science Lab. We are sort of party group. We do party a lot. So you can see we don't have a group picture yet because everybody's busy. Somebody's here, somebody's there. So we finally trying to have a group picture. But this is all of us, and some of new members have also joined. So group meetings happen over lunches and dinners. So I am still a very young person, so I try to live that kind of life. During COVID, I'm not sure whether I was the only faculty. I was told that at least in arts, I was the only got the permission to travel. So I work with NIH and other fields too. So I was traveling all the time, and you can see this is a San Diego picture. In San Diego Zoo, Japanese garden. This is how I used to work from zoo. Basically, take your laptop, work from home, and the good thing is everything was covered by corner. When you have money, all reimbursements goes to corner, so it's a sort of a paid vacation. And that was my New Year resolution that I am not going to pay my bills. So, thank you, Cornell. And Avicii song, right? They say you're going to leave this world, so live a life you will remember. And this is me. I'm not new to Cornell. I came here in 2011 as an MN student. Cornell made that mistake of giving me admission, and I have never left since then. And Ezra Cornell said, right, any person, any study. I took it literally. You can see I started from ECE, then switched to biomedical engineering for PhD, did a postdoc briefly in chemistry, and then got hired there. And so I know a lot of things in here, all of the faculty too. And this life motto is, I will be there whenever I need you. And somebody said it's a typo. I said, no, this is exactly what I mean. I'm there. So, yeah, so any questions? I'm more than happy to answer.
Yeah, hello, thank you for your presentation. It was very interesting seeing what you're doing here. I used to live in Sweden, and we have a lot of work on the demand side. And my question is, what other options, if any, did you consider when you were looking at the model for the demand side management? And if so, if you considered others, why did you choose this model?
I was thinking in different aspects. I was thinking in sort of nudging people, subterfuge, energy efficiency, sort of this kind of thing. But I went to Texas. Texas is a deregulated state. And I'm not there. For each zip code, you have 10 providers. You can choose your provider, you can choose your plan. In fact, you can choose not to get electricity during weekend. They give you credits, they give you bonuses the way you go for shopping, right? So these are all things happening, and I was surprised that Texas is so advanced. You can choose you want 100% solar. There's so many options happening. And I said, and Texans, they are proud Texans. They are actually very happy about it. Then I talked to people who moved from northeast to Texas, and a lot of people migrated at that point of time, especially during COVID. And I said, how does it look like? I said, this is exactly the thing I want. I wish I had in Northeast. That's how it came to the idea. And he said, what is the most sensitive thing you said? They said, I am willing to make changes the way I am doing it right now, provided I have a choice. So what is my sensitivity? Price is my sensitivity. Behavior change is not. And what I need, and I think the key here was not that you choose the lowest price. Question is what I am comfortable with. What is my predictable consumption pattern, and how much I am willing to pay. So that's the mapping. When I'm saying subscription based, that's the thing we are trying to map. And so this is idea, I got it from Texas, where people who moved from a regulated space to another space. Other option which I considered was, which nowadays some utilities are considering but already implemented in Arizona, is first pay then use. New York State has sort of allowed nowadays. So people prepay model. You buy a meter, you pay $200, $500, and then you use it. The problem with it is, when you have a lot of money, you tend to use a lot of energy, and when the money starts going, you start using less. And Uber drivers are good information providers. So he said, I use it. You know why bad? I said, why? He said, I was sleeping, and they give you half an hour notification. Oh, you are running low in your charge. Your electricity will be shut down. And he was sleeping, and his electricity was shut down. And Arizona is a very warm place. So he came to know when he got up with all his sweat. He said, I need to charge my thing. So he said that is not as effective. Prepay model in that aspect, because you have to keep track of it, and people are not consistent in their behavior. It's like when you get your monthly paycheck, right? You try to spend as much as you can, and then you have less amount of money than you choose. So those are the things I did consider, but I think I found that constant pay and constant behavior is the best way to go. That's what I thought based on those discussions.
Another thing that I also thought was, when you get in the beginning where you showed the structure, you had the generation side, the supplier side, and then you have this transmission, and then you have the users, and nothing much in between when you showed the structure of the bill. So the structure of the bill will put together both the generation and the transmission and distribution. Oh, okay.
Yes. So generation bills, yes, there is a utilities cannot charge. Their generation heavily depend on the supply side, whatever they are charging from the generator. But there is a certain cost they can vary. So they have a formula, already have a formula, so which incorporates transmission and distribution within that formula.
So it's not de-verticalized, the price, because in the northern parts of Europe, and I think even in other parts, because that's a requirement in the European Union, we have de-verticalization, and that putting together the price is a bit detrimental to actually also separating the incentives on the supply side.
Yes, and here they don't do it that well. Let's put it this way.
Yeah. In Sweden, you can sell electricity without being
Yes.
a producer at all.
Yes.
You could be just a distributor, just a what do you say, a middle.
Yes.
Yeah.
So in this case, it depends region to region.
Mm-hmm.
NYSEG is just a distributor. Portland General Electric is a vertical. They generate electricity too.
Mm-hmm.
So those sort of things based on utility and other local regulations. So those are, in US it is much more mixed bag. That's what I got from it. But as you correct, right, for example, if I switch to a digital bill, I'm still paying the rate for the physical bill. I don't get any benefit switching to digital. So they already charge it, incorporate it across the board at this point in time.
No, yeah, but I was thinking more like, for example, the transmission. That's a monopoly.
Yes.
Yeah, so it's a natural monopoly, and if you bundle the generation and the transmission, you can have cross-subsidization.
Yes.
And that's why it's very difficult to create incentives on the supply side
Yes.
if you bundle.
Yes.
And for the user, maybe not as useful, but in Sweden we do get it separately actually. The generation, the transmission, and everything.
No, I think at this point in terms of bills, we just get one bill, how much we use, what charge we use. I think that is the.
And then one last thing is You only have one here, one supplier, so you cannot choose the two.
Suppliers are multiple. You can choose your supplier. It's the transmission. The NYSEG is the infrastructure.
Transmission that you cannot choose.
Yes. So, for example, there's a solar. I can put solar on my rooftop too. So, supplier side, I have much more choices
Okay.
that I can choose to get this thing from that supplier.
No, but the supply of electricity is one.
Yes.
The
So,
supply of
yes,
electricity.
yes.
Yeah. That's another thing. In Sweden, you can choose the supplier. And so that even if the transmission you cannot choose because it's verticalized,
Yes.
but you can choose who you deliver.
Yes.
And the government provides a comparison of prices.
So this happens.
So this pushes very much the price.
This happens in Texas.
Yeah.
So this Texas
Yeah.
is that similar situation, and you will see very incentive.
Yeah.
Texas is electricity wise, they will give you all kinds of options. I was surprised the kind of you pay one thing but we'll give you gift card. Like and some people say, oh, cut off my electricity during peak hours for up to 2 hours. So those are the options they give because there's a deregulated market.
Yeah.
So and they give you weekly updates and whatnot. I mean, Texas in that aspect. You can see I want 90% solar, so they will make you pay. So you can have 3 months of contract with one utility, 9 months and 3 years. 3 years is cheaper. 3 months is not, because you can switch to other provider too, supplier. So that's where Texas is a case in study, where if I have to go next for 3 months, I will go to Texas and basically write down everything and implement in the Northeast. So it's a copy-paste model. I would like to do that.
2 questions, not one. 2 questions. Number one, how did you think of venturing from MS in EC to doing a MS in biomedical? Right now, I think the Department of Biomedical doesn't offer MS programs.
So I did my PhD. So I switched to PhD
You transitioned from MS to PhD in biomedical.
in biomedical.
So you did your 2 years as MS separately, or
No, it was part of the package.
Oh.
It was sorry. I think
So how was your journey? How did you get into a PhD program in biomedical, and what inspired you to do that?
I can answer that question offline because that's a long story. But my advisor was in chemistry.
Okay.
I talked to him. I wanted to be in EC. His friend at that time was department chair. He said, "But I'm a field member in biomedical. I can get you there. I have money." And so this is how it started. But I do want to mention, I may be the only student at Cornell, perhaps in US, who applied in February 2014, got admission in March 2014, and became student from January 2014 with expired GRE and expired TOEFL. You can talk to Belinda about it. The GRE. Right. So it was, my situation was not standard. This is not how I went to a standard. I said I had earlier did a project. I earlier had an advisor. So everything, the way subscription, everything worked backwards for me.
Yeah.
Now but I still do electrical engineering. So I am a computationally person, and even in chemistry I do data science. One of the projects I do want to mention, in case this is not the only area I work in. I'm also working with Cornell Police to study cocaine, heroin, cannabis. So basically, if you thought police cannot supply you cocaine, well, they are. So you can do big data analysis based on cocaine, whether they have the quality or not, how much contamination. Now there's a big problem. If you sell cannabis, some people mix heroin.
Yeah.
And some of the undergraduates have got excited because the cocaine captured from their dorm, now they can get back from police. so that's it. I think I started in biomedical engineering, but I can talk offline how it went. But my situation was, and that's how actually I work, get students, is first talk to students, there's an alignment, and then say, can you get this person admitted in that department, rather than backwards.
And the second question was, what do you think, since I'm from a biomedical background, so how we can apply your technique or the technique that you have talked about in regulating power consumption in medical devices? What do you think about that?
depends on what medical device you are talking about.
Yeah,
If you are talking
about those devices like MRIs and those who have like higher electrical consumption.
So I also work on MRI. That is how one of my PhD area was. The challenge there is it is not going to work because it is paid by insurance.
Okay.
So that's an insurance thing and they charge it. So if they reduce it, they have to get less reimbursement.
Oh.
So medical profession is all in that aspect. Insurance is paying me higher rate. Why I should be efficient to get a lower rate? So in those devices, no, but implants, yes, because then the energy efficiency becomes an important part. But MRI, helium, they have not got rid of helium or helium-free system because reimbursement.
The pricing is structured that it can operate 24 hours, and because the risk of not doing that due to budget is not acceptable.
Precisely.
So now they bill you for the price, basically, as you run it the whole time, break it by that session, it's premium.
And I will tell you another thing which nowadays big medical schools are doing. Brain scans are most common, and also reimbursement is being reduced by insurance. What they are switching to is other body scans, other diseases, not tumors.
Different code.
Different code, $4,000 for child, $700 for brain adult. Why would you like to do adult brain? Child brain for the same time is much more profitable. So they have their problem there is the insurance rate. So who is paying? And this is what the problem with utility, right? If I am willing to pay higher prices, why bother? Right? But nowadays there's a public backlash, right? So that's the media news is coming. That's why they have to change their behavior. And when you have blackouts, trust me, in winter nobody likes a blackout. So that's where they are changed. Not that they are prone to change. Shikhar can talk more about it. He used to work there. So and he can describe how the environment was. So let me stop sharing. So any other question from the Zoom audience?